Okay, we're ready to start this session. Before we get going, I want to ask a question of the audience. How many people in the audience are primarily involved in surface ship engineering and construction? Oh, good. Because I have a little bit of advice for you. I've noticed over the years that folks are fond of saying, go see what Odense is doing, or go see what the Korean yards are doing, go learn about shipbuilding in Europe. And I would tell you, that's a good thing to do, but on your way there, stop at Quonset Point, Rhode Island, and see how we build submarines today. Because one of the things you're going to learn in this session is a little bit about the capabilities that exist in the United States for the most modern kind of shipbuilding program that exists anywhere on the planet. It's a great honor to be able to participate and to introduce this distinguished panel. Admiral Javellet has cautioned me not to wax too enthusiastic about their bios, so I'll just tell you that collectively there's a lot of knowledge about submarines and submarine programs and the funding of submarine programs at this table. Admiral Javellet has a great career as an operator and as a Virginia-class program manager and now PEO submarines. I know that's a great job because it's a job I once had and I enjoyed it immensely. And Captain Goggins has been deeply involved in Virginia class, and so he understands very well how that works. He's spent a lot of time working on submarines that have set the pace for the United States Navy. George Drakely started life in the nuclear cruiser business, and he's had a very long and distinguished career in technical management at the Naval Sea Systems Command and is now the deputy in PEO submarines. Mike Breslin is a longtime technical director in submarine programs, so there's a lot of NAVSEA submarine knowledge. Next to Mike is Will Lennon, who's the Vice President for Design and Engineering now at Electric Boat. That is one of the two greatest jobs that a person could have in this business. Will has brought with him a very interesting and extensive discussion of how the Ohio-class replacement will be built at Quonset Point. And last but not least, and first in the program actually, but not least, is the guy at the end of the table who's the programmer in OpNav, for whom getting the money and holding on to the money and making the money available to the program is a very, very demanding task. And so I'm sure if we could look at his back, we would see all sorts of knife thrusts and so on as he has defended this budget. Well, this ship, of course, is a follow-on to a great submarine program, the Trident program, which was pace-setting in its own way, and that follows in the footsteps of the famous 41 for Freedom. So these submarines and these programs have been sustaining the strategic deterrent in the United States for a long time. And this submarine will continue that almost to the end of the 21st century. Without further ado, we'll kick it off, and I think first up to bat is Captain Boehning.
Hopefully this works. Well, good afternoon, and thank you for the opportunity to speak here today. As you mentioned, I'm Captain Mark Boehning. I'm the branch head for Sea-Based Strategic Deterrence at N97 on the Navy staff in the Pentagon. I'm charged with providing resources and requirements for all things related to SSBNs. That includes existing Ohio-class submarines, the Ohio Replacement Program, as well as nuclear weapons safety, security, and compliance. SSBNs, by virtue of their survivability, are an essential part of the nation's nuclear triad. The entire SSBN concept of operations, or ConOps, revolves around maintaining an adequate number of platforms at sea and survivable to provide a credible, assured second strike capability. On patrol for months at a time, our SSBNs ensure no country will ever threaten our survival without knowing with certainty we will respond at a time and place of the President's choosing with credible, devastating combat power. We do this in 2 oceans, 24/7, 365 days a year. This year will be 366. And we've done it for over 4,000 times over the last 60 years without skipping a beat. It can be easy to take for granted that this day-to-day commitment to the nuclear mission is what has helped take major power war off the table for resolving conflicts. But let me be crystal clear about the next point. It's not because weapons and adverse efforts went away. It's because people with the weapons made calculated decisions and were deterred. While some may not be aware of what we do or why we do it, we do understand, we do care, and we remain deeply committed to the successful execution of this mission. The nation demands it even if we may not fully realize it. So right now, it takes 14 Ohio-class SSBNs to execute that concept of keeping the right number of platforms at sea and survivable. Survivability is not dependent on the number of warheads. The SSBN force is sized to keep the right number of platforms in the right place and in the right posture at all time. Geography, survivability, and target coverage are in fact the primary drivers in sizing the force, not the total number of warheads. After an extensive engineering analysis determined it was feasible and safe, we extended the service life of those 14 Ohio-class SSBNs by 12 years, from 30 years to 42 years. That's a true testament to those who design the ship, those who maintain the ships, and the forces that operate the ships. However, there's absolutely no margin left to extend Ohio any further. The Ohio replacement SSBN has incorporated design changes that enable 12 Ohio replacements to do the work of 14 Ohios. An unprecedented 42-year life of ship core and a 10-year propulsion shaft or life are a couple of examples that will allow a smaller SSBN force structure. Reducing the number of SSBNs to 12 will save the nation over $40 billion in valuable resources over the life of the class. But make no mistake, replacing 14 Ohios with 12 Ohio replacements leaves less margin to meet the mission. 12 Ohio replacements provides the sufficient force to defend us through the 2080s. 12 is the minimum force structure required to meet STRATCOM requirements. It's a balance, and we're being good stewards of taxpayer dollars while delivering the right number of boats with sufficient capabilities necessary to keep the nation safe in the future. The requirements, finalized last year with the approval of the Ohio Replacement Capability Document, were a result of a dedicated team working over a span of 5 years focused on ensuring this single mission platform delivers the necessary capabilities to be a viable sea-based strategic deterrent through the 2080s. Excess was not an option. Captain Dave Goggins, the Ohio Replacement Program Manager, and his team work hard every day to meet those requirements while still building affordability into the design. Making the force lean like this saves money, but also applies pressure to continue delivering a demonstrated credible capability that we and our allies rely on. It is part of my job to make sure we do not become too lean and ensure the warfighter is provided with the right capability and performance. The key to balancing mission capability, cost, and schedule is stable but rigorous requirements and the technical rigor associated with executing those requirements once set. Ohio Replacement's technical baseline is established, and the Ohio Replacement team is working every day to make sure that we stay true to that technical baseline. Some may question the ability to know what the undersea domain will be like 70 years from now. We certainly don't have a crystal ball, and those kind of predictions are challenging at best. But I will tell you, we have a dedicated program, the SSBN Security Technology Program, or SSTP. They work this issue every day. They are chartered with the sole purpose of ensuring SSBN security and have been doing so for the last 47 years. They are unique in that they not only work with the intelligence community to understand what our potential adversaries may be doing, but they also take a physics-based approach to determine what is within the realm of the possible. SSTP had significant input into crafting Ohio replacement requirements to make sure this platform will stand up against the uncertain of the future. In closing, I want to reiterate that we are maintaining focus on the long-term requirement for nuclear deterrence. We are taking action today to maintain stable and executable requirements that ensure Ohio replacement is delivered with the right capabilities to last until the 2080s on a schedule that meets national requirements, all while executing in an affordable and cost-effective manner. Thank you.
The next speaker is Will Lennon, and Will remind us how these strategic submarines were built in former programs, and then talk quite a bit about how they're going to be built and are being built now in the Ohio replacement. Will.
Thanks, Admiral Fireball, and I'd like to thank ASNE, Admiral Jabaley, and the rest of the panel members for inviting me to speak up here and relay what, in the submarine industry, what we've been able to do over 3 generations of strategic deterrent design and construction. If you look at the slide up front, on the left is the George Washington, the first strategic deterrent submarine. In the middle is the USS Ohio, the first Trident-class submarine, and on the right is the depiction of what the Ohio replacement will look like, which will enter and do its first patrol in 2031. So if I jump back to how did we build George Washington? Well, George Washington started as a skipjack-class submarine. It was cut in half. A 133-foot section was added, which included 16 missile tubes. You can see through the pictures at the top right, there's a hull cylinder under fabrication, and the amount of structure and things that were kept to build the hull and make it circular in the right side. The next picture over, going right to left, is putting a bow section on. Again, all done in very adverse conditions. The missile tubes is the next one over. That's building missile tubes out in the weather with absolutely no outfitting done on them at all. And then the bottom, or excuse me, the top left, you can see 4 people down there sliding a tank into the bottom of the hull cylinder. So that was modular construction at the time, was you built it and then you manhandle things into place. And after the ship was built, we slid it into the river, which limited your capacity for the size of the ship and the amount of outfitting you could do, because the ship would literally become too heavy to slide down the ways without getting stuck in the mud or going over to the other side of the river. So you did have limitations back then. On the Ohio, we started the introduction of modular construction and manufacturing hull cylinders and separate deck packages, which could be built independently, and then the deck section slid into the hull cylinders and erect the hull in larger pieces. That was the start of modular construction. We started it up at Quonset Point. In 1979, we put an automated frame and cylinder manufacturing facility up there that highly automated the manufacturing of hull cylinders. It improved our productivity, therefore reduced our cost, and absolutely improved our quality. It took about 49% out of the cost to do the job, and it really was a big benefit to us in the manufacturing. In Groton, where we did final assembly and test, we integrated this land-level construction facility. That eliminated the need to slide the ship into the water. We had a progressive workstation concept where cylinders would be lifted with a crane off of a barge and brought into our assembly hall, where those deck packages would be loaded and cylinders combined until ultimately you got to a final hull erection state, and then you brought it out onto a launch pontoon and launched the ship in a much completed state, usually up around 85%. As transportation and infrastructure improved over time, we were able to increase the size of the packages we were manufactured up at our Quonset Point facility, from just larger hull cylinders to hull cylinders that actually the end loads of the deck structures were put in up at Quonset, and we could bring the bigger package down to Groton and minimize the amount of outfitting that we were doing on our Groton waterfront. On Virginia class, we took it to the next step. We increased the amount of vertical outfitting we could do. The advancements in accuracy control allowed us to build much larger packages across 2 shipyards, Newport News and Electric Boat, and join those packages together with a high degree of confidence that the whole ship would go together and have no mismatches. We increased the amount of modular construction we did at our manufacturing sites, which dramatically reduced the cost, and we got to the point where we introduced a 4-module build plan. We continued to advance automation. We put in a light metal fabrication system that automated downloads from our design tool into our shop floor that allowed us to cut and form both light metal fabrication and medium plate. We looked at steel processing and how we could laser mark and form plate rather than cut and weld into sections. We took downloads from our pipe system in the design and used automated bending and got rid of about 40% of the fittings on the ship and used bends instead of fitting. And we're carrying that even further on the Ohio replacement program, where we're using the ability of our laser cutters to cut intricate shapes out of sections of steel, and we call it self-fixturing decks, where we can use the decks to interlock with various pieces and simplify the mechanism by which we assemble and weld the pieces together. I mentioned earlier we put a 4-module build plan in place on the Virginia program, where 4 large modules were built at either Quonset Point or Newport News, and then the modules were shipped to the final assembly yard, again at Groton, Connecticut, or at Newport News. Ohio replacement will take off of that same build strategy. We'll use a 6-module build plan. The big difference will be is this ship is 2.5 times bigger than the Virginia. The Virginia build plan uses a barge system that has a 2,000-ton capacity. On Ohio replacement, we'll have a barge that lifts up to 6,000 tons to bring in these 6 large units into the Groton shipyard for final assembly and test and delivery. The one thing we couldn't bring forward from the Virginia class was how to build a missile compartment. The last time we did that was on the Ohio class. The picture on the left shows the Ohio class missile compartment construction process. We would bring an empty hull cylinder down from Quonset Point, cut 24 holes in the top, and load missile tubes in one at a time and weld them into the ship. At that point, anything that attached to the missile tube or into the surrounding areas, along with the people who had to do it and the services required, whether that was welding leads, ventilation, or anything else, had to be brought either in through the ends of the hull cylinder while they were still open or through the ship's access hatches after pressure hull complete. A very inefficient way to build the ship. So on Ohio replacement, we introduced the concept of a quad pack. We'll build individual missile tubes. They'll contain a small section of the pressure hull at the top. We'll be able to fully outfit those missile tubes in a manufacturing environment, join the missile tubes together, and then wrap the pressure hull around it into that 4 missile tube section called a quad pack. We then join those quad packs together. On the U.S. submarine, we'll have 4 quad packs for 16 missile tubes. This same missile compartment's used for the United Kingdom successor program. They'll use 3 quad packs for their missile compartment. And that's how we'll build the missile compartment on the Ohio replacement program. This technique will save about $45 million per ship by moving all of that work out of a closed hull, expensive outfitting environment back to a much less intensive manufacturing environment at Quonset Point. In order to accomplish this, we built a building up at Quonset Point. It was finished last September, and it's specifically made to manufacture hull cylinders and quad packs. You can see a picture of the building on the left, and on the right is the actual floor plan. The bottom set of fixtures are used to fabricate the hull cylinders, and the top row is how we fabricate the quad packs. If you look at the top row, there's 3 sets of fixtures there. The center section is what's called an R fixture. We bring in our missile tubes from our vendors, and we use the R fixture to outfit the missile tubes, allowing us to rotate the missile tube and install the packages in a very efficient manner. We then move the tubes one at a time over to the left fixture, which is called an E fixture, where we join the missile tubes together to form a 4-pack. And then we take the 4-pack all the way over to the right and put it into the hull cylinder and form the quad pack. This building is being outfitted right now, and we'll start this quad pack manufacturing for the lead ship of the U.S. program in 2017. All of that in advance of the UK successor program, so we can validate both the design and the manufacturing process before they do. We have a short animated video of how this will operate that I'll walk you through now. So that's a completed quad pack. We're going to go by the 4 fixtures that are being installed now, which we use to fabricate a hull cylinder. That's very consistent with the way we do it on Virginia today. They're just newer, upgraded fixture for the larger hull diameter. So we rotate around. You can see the center section where the R fixtures are. There'll be 241 missile tubes that come in through that garage door, and get outfitted on the R fixture. We lift them off the crane, put them on the R fixture. That allows us to lift on these piping packages, structural packages, and do electrical outfitting, always working in the down hand position in a very efficient posture for the mechanics on the shop floor. We outfit all the missile tubes in this fashion, and at this point, the ones that would go to the UK are put on a barge and sent over to the United Kingdom, and the ones that would be used for the US ships are transferred into the E fixture. You can see the small gray section at the top of the missile tube. That's part of the pressure hull. So we bring in a tube that is on this case, the starboard side of the ship. The next tube that will come in would be the port side mirror image of that missile tube. We do the vertical seam weld between the pressure hull, put in some deck structure, and then bring in the next two tubes, do the vertical seam weld between those two tubes, then lower it down and do the horizontal seam weld of the hull section between the four tubes. At that point, we put in some robotics that are used to cut and bevel the end of the tube and will actually be used to weld the bottom of the missile tube into the hull cylinder. We then transfer the entire package over into our F fixture and insert it into the pressure hull. The pressure hull was prefabricated over in those four fixtures we saw at the beginning of the video, brought over into this F fixture. The top portion is cut out, and it's ready to receive the 4-pack of the hull cylinder, of the missile tube, excuse me. We have the ability to do very tight alignment of the 4-pack into the hull cylinder so that we meet our circularity requirements and also meet our alignment requirements of the tubes to the hull. We then use the robotics to weld the bottom of the missile tubes to the pressure hull, and then we move to the top and weld in some margin plates from the missile tubes to the pressure hull. At that point, the quad pack is done, and we can pull it back out, the robotic equipment back out, open the doors, and transfer that to an area where we would position the quad pack into the axis horizontal position and join it with the next quad pack. So that's the unique way we're going to build the missile compartments on the next generation of ballistic missile submarine. All at about $45 million savings per ship because of the highly automated fashion that which we're going to do it and the extremely worker-friendly environment for which this work is done. Okay, if we could go back to the slide. So where are we? So the first 17 tubes for the US and the UK are actually under construction right now. That's 12 for the first ship of the UK successor class, 4 for the first article quad pack, and 1 that goes down to a test facility in Cape Canaveral, Florida. The F fixture, the one that the 4-pack goes into and is welded into the hull cylinder, is actually going through qualification testing right now. I'm going to show you another animation. The bottom right is an animation of the electronic build sequence which we developed to validate the design electronically. And the top left is the vendor who built the fixture for us, also built a mock pressure hull and a mock 4-pack of missile tubes, and is doing the qualification testing right now to validate that the whole system and process works. If we could run that video, please. So the bottom right is our computer-generated electronic build sequence, which we use to validate the design, and the top left is the vendor performing that same evolution with prototype hardware in his fixture. That testing will finish up this summer. That fixture will then be sent to Quonset Point for installation. So the program has come a long way from initial concept designs to validating the way we're going to build the missile compartment. So all in all, we've come a long way in 3 generations of ballistic missile submarine construction. The tools and the processes have allowed advanced manufacturing. We're incorporating a 6-module build plan which will deliver modules the size of many ships, but that's the most efficient way to build them. These new innovations will reduce cost, improve our quality, and support construction schedule improvements all through the class. And the lessons learned will also be applied to our Virginia payload module design development effort, which is ongoing now for the Virginia Block 5 contract. So with that, thank you.
talk about technology development in the Ohio replacement program.
Thank you. Thank you, Will. That was a great explanation of the technology that's used to build the submarine. Now Mike Breslin and I will talk about some of the technology that's going to go into the submarine to allow it to function safely and in future threats through the 2080s, which, as you can imagine, is quite a feat to figure out what technologies are needed there. When Mike and I talk about technology, what you'll probably hear a lot of times, though, is cost. The big driver for us in deciding what to do for the technology was to ensure we did not, to minimize the cost and still get the best platform going. And so one of our concepts in developing that technology really was to leverage as much technology from the Virginia class and the other Navy platforms. That's one reason why the missile system is carry through from the Ohio. It's the updated Ohio missile system, and that helps us keep down developmental costs and building costs and fielding costs. So we use that concept a lot. The Virginia, after all, is a very successful program. It's the best submarine out there, and it has the most advanced technology. So where we can, we use that technology. One of the main areas that we had to focus on was acoustic stealth, and in that area, we had to do some development to go beyond Virginia, because to survive the future threats, we determined that we needed to be even better than Virginia when it came to acoustics. But pretty much other than acoustics, we leveraged the technology. For example, we used the air conditioning plants, the same design as Virginia, just upgraded in size to handle the larger submarine. And we leverage a lot of what we do in the construction. For example, we are using a similar combat control module that Virginia uses. We're just putting pretty much the same module into the Ohio replacement. That not only saves us a lot of developmental and construction costs, but allows us to leverage the technology from the attack submarines combat systems. We're not developing anything new. We're using the same swiftest system that the submarines are using. It allows us to keep the Virginias up to date along with the rest of the submarine community, and it makes it easier to maintain. It's the same maintenance philosophy, same maintenance training as the attack submarines, so much cost reduction there. We're leveraging a lot of the Virginia design for affordabilities, the kind of sonars they have, and all to keep all of the acquisition costs down and still meet all the requirements for this submarine. One of the key things is Virginia was a design build kind of concept, and OR's taken it to the next level, and we're a design build sustain concept, and you'll hear Mike talk a lot about the sustain part. Because we're down to 12 Ohio's replacements to replace Ohio, they have to be able to get turned around quickly in port and maintain schedule, and so that put an emphasis on the technology required to sustain it. For example, we had to develop a shaft that is a greater than 10-year shaft to allow the Ohio replacement to go longer between dry dockings than Virginia's do right now. And I think Mike will talk about that some. So I'm going to turn the microphone over to Mike Breslin to speak some of the specifics and specific components that we are using to ensure we have a platform for the next 50 years.
Like George said, there's a couple of main themes we have when we are designing and building the ship, and it's to reduce risk, and both risk in the construction, which has a lot to do with how much of the design we get done prior to actually starting construction, and also to reduce the risk of the sustainability of the ship. We have a very explicit maintenance requirements and dates that we have to do that to maintain a strategic deterrent ship. So we have to meet those dates, or basically we fail. So everything that goes into the design of the ship has to have sustainability taken into account. Along those lines, to reduce both the risk and increase the sustainability, the two major themes is pull through from, like George said, from both Virginia and Ohio. To just go through some of those examples, things that we're pulling through in Virginia class, we have a Virginia-like propulsor. It's going to be more advanced in Virginia, but basically Virginia is the baseline for that. We are using universal modular mass in our sail, same as Virginia, And also to aid in construction and maintainability, we have rafted decks, similar to Virginia also. The ship control system is a pull-through from Virginia, and obviously upgraded to meet the OR's requirements. But to reduce risk there, we have a very comprehensive ship control station test facility up at Electric Boat, where that is constantly with the electric boat engineers or have the ability to test that real time up there and bring crews in to work on that to make sure that the concepts work and reduce the risk there. The towed array handling, the towed array system, not the handling, the towed array system itself, we use the same sensors as what's out in the fleet right now. The NPAS will be a pull-through, the non-propulsion electronic systems. And unlike Ohio, this ship will have hull coating on it, which brings some unique sustainability requirements it will have to meet. So we have to work through that, but it will have hull coatings like the fast attack boats have out there. It will have Virginia-like torpedo tubes. For the most part, we pulled through the entire torpedo room from Ohio class and adapted it into the OR. There are some things that are different, but for the most part, once you get in the space forward, it is a Virginia torpedo room. We are also having a large aperture bow array similar to Virginia, and some of the other components, ICCP and Circuit D, are pull-throughs from Virginia also, which helps us a long-term in sustainability and in maintaining obsolescence, since we'll be supporting both ships of both classes of ship. Our weapon shipping handling system, the portions that are on board the ship, once you get forward in the torpedo room, are a pull-through. Outboard, we do have some unique challenges there that are a little bit different than Virginia, but half of the system is a pull-through. We're using numerous pumps and valves straight off Virginia class and using them. Like George said before, we do have some other additional acoustic requirements that make some additional development. We're pulling through the sanitary system from Virginia class, a lot of similar heat exchangers, and we're also putting on an integrated low-pressure electrolyzer, which is off Virginia class. We're putting in the advanced unit, which is also going to go in future Virginia class ships. So that's working together on that. Systems that we're pulling through from the Ohio, like we are pulling through the strategic weapons system. It's still going to be the same missile system. Also, the weapons system support systems are all the same from Ohio. The missile compartment is for the most part the same. Some of the other components, the comms buoy, emergency beacon buoy, and we are going to have fairwater planes on this ship, the same that we have on the Ohio class, unlike Virginia that has bow planes on it. Some of the new development items we're using, it does have a different propulsion train. It's going to be electric drive. It's also going to have a quick disconnect duct, which will aid quite a bit in sustainability of the ship. It's going to have an advanced propulsion bearing, which will aid in some of its requirements, unique requirements. We're improving on the shaft bearing journal to try to alleviate some of the problems that are out there in the fleet, so we're adapting lessons learned from the current fleet, the current ships that are in the fleet right now. It's also going to have a tapered shaft and a dual block hub, which will aid a great deal in when we have to pull off the propulsor in any sort of maintenance availability to meet our short availability times. We're having a coordinated stern, which everything kind of works together on that. And Mr. Lennon spoke about before, the integrated tube and hull construction is very unique, and it's actually, those videos I like them every time I see them. It's very cool to see how that's done. The fact that we're building stuff outside and putting it together on the ship like that. We have a unique diesel generator. We are having a diesel that's similar to Virginia. It's unlike Ohio, but we do have additional power requirements on Ohio that we don't have on Virginia, so we have to develop that. One other unique thing we have out is an autoclave sonar dome. An autoclave is basically a big kiln. There's not an autoclave in the United States that's big enough to put in an OR bow dome, so we've developed a process to build an out-of-autoclave bow dome, so that is a developmental effort. The air conditioning plants, for the most part, are pull-through, but there are some things that have to be developed to meet our requirements. We're putting on what we call an ACRU, or an advanced carbon dioxide removal unit. That's going to be a big quality of life help for the sailors, because it removes liquid amine from the ship, Anybody that is, yes. It's a couple unique smells on submariners after they've been at sea for a while, and one of them's amine. We're hoping to remove that. So we're working on that. It's also gonna have an electronically suspended gyro, a replacement for the current ESGN. It is gonna have a different type of thin line towed array handler than the previous class ships. Once again, we're trying to leverage off lessons learned from various systems in the ship that have had some problems previously. The ship is also gonna have a large vertical array. The main goal here, like I said, was to reuse a lot of the equipment that's out there, adapt what we have so it's not pure new engineering, so we do more engineering than development. The whole idea is to deliver the required capability at a reduced cost. This is just a, yeah, right here is just an overview of our technology development roadmap. I'm not going to go through the various lines there, but what it does show is that various things and various ways that we're doing it. Some of the tests on here that we're using out there are on current fleet ships. We're testing things out on there for development here. We do have a large variety of various test facilities, from a large-scale bearing facility to we actually have scale model propulsors that we can test on test devices, and a lot of our development or our support equipment's being worked. So some of the highlights that we've done, some of this is redundant, but I talked about some of the design processes. The auto autoclave bow dome is huge. We're also having go through the missile tube hatch shock qualification. We're trying to pull some of that through from Virginia class. Also, we have some high capacity mounts. Why that's a big deal is we're trying to minimize the maintenance on the ship, and we're trying to create life of ship components, and this being one of them. Some of the things I talked about before, some of the developmental efforts. Like I said, we have a full-scale bearing test facility that we're utilizing. We are doing stern assessment trials on various sea trials on other class ships. We're also looking at an advanced hybrid propulsor, and we are capable of testing large-scale propulsors for that. Our ship, like I mentioned before, our ship controls station up at EB is a huge help in developing that and bringing fleet operators in there to get real operators to operate what we're developing and get their input. Some of the other things we consider more engineering than development, like I said, the ACRU, or the CO2 removal unit. The technology is there. It's a matter of engineering it and adapting it to our requirements. And that is also true for the new low-pressure electrolyzer. We are putting in a battery monitoring system, which we're trying to make that, there's going to be several models out there.
Very common.
Very common with the other class ships out there that have them. Same with heat exchangers. We do have to, due to some of our unique requirements on our ship, we've had to adapt the air compressors or high packs to this. Like I said, that's more of an engineering effort than a developmental effort. And that's the same with our reverse osmosis unit, which makes our fresh water. We're pulling through the Sea Sentry radar. We have been able to do some good engineering up at EB, reduce the number of ship service hydraulic pumps on the ship, which is huge in the sustainability and maintainability of the ship. And that is also true with the trim and drain priming pump. Like I said before, our effort here is a combination of reuse and engineering and some development. The whole point was to try to reuse as much as possible. And with that,
All of these matters come to roost on the shoulders of the program manager, who has to coordinate all this and has to keep the money supply flowing from the Pentagon, from his colleague at the other end of the table, has to answer a lot of questions, has to spend a certain amount of time romancing a group of folks over in the Office of the Secretary of Defense, which takes a lot of time and energy and view graphs. And he often has to answer many really not too relevant questions, and he has to do that with a big smile, as though it was the most important thing anybody'd ask him all day. And that's the program manager, Captain Dave Goggins, who's going to tell us about the program.
Thank you, sir. Hey, it's great being here. I do want to reiterate. You heard the word design, build, sustain. Virginia class was design, build. And I'll tell you, a high replacement is design, build, sustain. Mr. Breslin is my technical director, extensive design experience, but also very extensive in-service experience. Below him is our ship design manager, Anthony Malarkey, also very extensive in-service experience. So I'll tell you, as we design this submarine, my team is really focusing on design, but also the operational support aspect of this, make sure we get the maintenance correct as we do our design. So overall, what's key about this program is we got to deliver a capability on its first patrol in 2031. In order to do that, there's really three prognosis that the efforts have to be aligned programmatically, the funding, and the work we're doing. Now, it's the efforts between Naval Reactors, my office, PMS 397, high replacement, and the work done by SSP under the leadership of Admiral Benedict. So you start to look at this chart, the work we're doing in my office is really leveraging the lessons learned from Virginia class, the modular build, taking their 4 module build, going to our 6 module build, the Coordinated Stern work that Mr. Breslin talked about. The work being done by Naval Reactors is the electric drive, the life of ship reactor core, and the work being done by SSP with the D5 life extension work they're doing. So key thing here is 3 efforts, 3 prognoses. The efforts got to be aligned in the funding. I'll provide you a pretty high-level overview of as a program manager, I got to show you my program slide and my key events. So the very top there, a lot of stuff, but I'll just highlight a couple of key points. Last year, we had what we call our Gate 4 meeting. The gates are really a internal Department of Navy meetings to ensure alignment between the resource sponsor and the acquisition chain of command. And we had this Gate 4 on November 13th of last year on a Friday with Secretary Stackley and the CNO. The main focus is really to ensure we've locked in our technical baseline. So as Captain Mark Benny mentioned earlier, last summer we locked in on the CDD, the Capabilities Development Document, that locks in the requirement that I got to go provide to the fleet. Right below that is what we call our ship specification. That was also completed. So really that's how we define our technical baseline, the CDD, the ship specs. We're not changing that. And if we do, I have to go back to Secretary Stackley and the CNO get approval to change that. The reason that's important is you lock that in, allows my design agent, Electric Boat, Mr. Lennon there, to go through the design process as efficiently as possible without worrying about higher level changes to requirements. That was done last year, November, the Gate 4. Shortly after that, we released the RFP for detailed design. That was released in January of this year. And now you'll see in the milestones there, the next big milestone is this summer. We'll have a milestone B with Secretary Kendall. That's to get approval to go in the next phase of our acquisition program and really get into detailed design with the Electric Boat in this program. Coming down, you'll see the under contracts. And that's what I talked about. You'll see that long line going from 2017 through 2030. That is the SCN detailed design contract. Really 3 phases there. The first phase there is with the design agent coming through the design, getting through the arrangements, design disclosure. The next phase is providing design agent support as we build the submarine, as we identify technical issues. The design agent will provide the support to get the right technical solution. Then also design support after delivery as the boat does its government testing. We have design agent support there. On the bottom there, you'll see the construction spans for our 12 ships. The first one starts construction in 2021, 7-year construction span, then a 3-year period for the shakedown period doing the government testing of acoustic trials, the work done by SSP, and then it goes on patrol in 2031. Provide you a high-level overview of where we are with our design. So you look in the middle there, you'll see a line that has CMC and then ship arrangements. The next line down, CMC and then detailed design. Today, our main focus is really working in the CMC first, going through our arrangements. So our team working with the design agent, my team in my office, and the sustainers going space by space and really arranging where the systems go, where the pumps go, where the valves go. And as we do that, we got the builder part of the team to make sure they can go build that efficiently. We also have the sustainers part of the team to look at it from a maintenance perspective. Can they get access to the equipment? Do they have the right flow paths for material and pumps and valves to meet the maintenance requirements when these submarines are in service? Once we get through arrangements, we'll have those all done at construction start. And the next step really is once the arrangements are done is we're now starting to get into detailed design. Those are the design deliverables to the shipbuilder on how to go build that platform to the specifications of our program. You'll see down there too, we have a line which Will talked about, Mr. Lennon, about the ITH to the missile tube. That's really the work that he showed you in the videos of starting off with the 17 missile tubes, building the quad pack, and leading up to really building the missile tube module early in the program to retire that risk before we start construction with lead ship. Below that, you'll see the successor program at the UK. They'll actually start their construction this summer using the design work of the comm missile compartment we're designing with Electric Boat. And then you'll see we start construction on our platform in 2021. That concludes my discussions, and thank you.
All right, next, the PEO submarines is going to wrap this up, and then we'll take questions. When you want to ask questions, there's microphones that are in the aisles there, and you can go to one of those microphones and ask your question. So, Admiral Jaboulet.
Thank you very much, Admiral Fireball. I want to stress a couple of points that were made by my co-panelists, and then close with a final discussion. So if you go back to Captain Mark Benning's discussion on requirements, one of the things that is at times floated in editorials is, well, you know, we obviously can't afford this platform. Maybe we should only build 8 of them or 10 of them. That would probably be enough. And it's usually in the same column as a thought that, well, you know, we have all these thousands of warheads. We could probably cut 30% of them. That would probably be enough. The problem with that is, and Mark said this, but I want to illuminate it. The strategic deterrence requirements really drive the number of platforms more than they drive the number of warheads. And I can't walk you through the entire process that results at the number of 12, because most of the factors that go into it are classified. But it involves things like historical data collection that tells you exactly what we know our operational availability to be for a platform. So we know with fairly reliable statistical accuracy what the probability is that an Ohio-class SSBN will come out of a refit on time, whether it will have a material failure at some point during the patrol. And so all of those factors go in to make sure that we always have not only enough ballistic missile submarines at sea on deterrent patrol at any time, but that we also have enough that we can scramble in case we either have a phase of elevated tensions or we need to replace one that's out on patrol. So when you say, well, we should only build 8 Ohio replacements, that is a budget-driven strategy of deterrence, which is not something that we want to do. You know, we start with options that are available to the president, and then you walk it through a very detailed process that ends up with, I need 12 Ohio replacement SSBNs because I know that 2 of them you know, we're going to be offline in depot level maintenance at any one time, and then it just walks on through all of those factors that are more classified than that one. So, you know, the number of 12 is the requirement given the national deterrence policy that we have to provide. The second one, Will Lennon's great explanation of how we build the integrated tube and hull using the fixtures to result in the quad packs that make up the missile tube or the common missile compartment. And he mentioned, you know, the total amount of tube work that's going to be going in that building. Well, the one thing to add to that is there is a similar effort with the Virginia-class submarine, the addition of the Virginia payload module starting in Block 5, that is going to result in another group of 87-inch missile tubes being built in much the same manner as the Ohio replacement tubes. You know, so it's going to be really over 350 tubes when you add up the Ohio replacement tubes, the UK successor SSBN tubes, and the Virginia payload module tubes for Block 5 and beyond. So a phenomenal amount of work, and that drives the need to make it as efficient as possible. The fixturing and manufacturing process that we've arrived at is going to do just that. In the area of technology development, one of the most fascinating and interesting things that Mike briefly touched on was the coordinated stern. In previous classes of submarine, we designed the rotating element. Used to be a propeller, then it became a propulsor, and that part of the system, not in a vacuum, but certainly not in coordination or conjunction with the rest of the stern system. And what we have known but have not been able to design, we now are able to design based on advances in computing power, advances in computational fluid dynamics, and advances in the art of naval architecture. So the interplay between the propulsor, between the movement of fluid across the hull of the submarine and into the propulsor, all of that is now taken as a whole. And it's a very exciting field, and it's one that's going to result in a significant advantage in the acoustic performance of the ship. And it's just one example of a lot of things we're doing, many of which, of course, are classified, that will make sure that this platform maintains an acoustic advantage throughout the entirety of its life, out into the 2070s, 2080s. Let me go back to, if you can pull up the slideshow again, and this one. Okay, and I'm gonna see if you can see. So in this bottom part here, one thing I want you to imagine in this big white space is a set of matching bars for the Ohio class SSBN. And when you get to this blue thing here, which is the first Ohio replacement on patrol, you have to understand that it is heel to toe with the decommissioning of the first Ohio class SSBN, which is now actually the Henry M. Jackson, because we converted the first 4 Ohios to guided missile submarines. So the 14 Ohio class SSBNs we have really fit lockstep into this puzzle. And what that means is when Mark Benning said and when Dave Goggins says that there's no margin left in this program, it really means there's no margin left. We have to have that first boat on patrol in 2031 because the Henry M. Jackson is going away and we can't extend them. So, and then for each successive submarine, there's a similar flow. The next Ohio goes away and the next Ohio replacement has to be out there taking its place. The point here is that particular thought illuminates the importance of this program and really puts a spotlight on our adherence to cost and schedule and getting the ships built on time. However, the mirror image of that is a similar effort which is going on within Team Submarine, and my colleague, Rear Admiral Moises del Toro, who is Deputy Commander for Undersea Warfare at NAVC, so NAVC 07, he is tasked with the effort of making sure that the Ohio-class SSBNs make it across the finish line. Okay, so the same problem we have if we fail to deliver Ohio replacement Hull 1 in 2031, we have a similar problem if Henry M. Jackson can't continue on strategic deterrent patrols until the first Ohio replacement is ready to come out and take her place. So it's really two sides of the same coin. We have to have the ability to maintain our strategic deterrence, and doing so requires both an innovative construction process that gets the boats out on time and a classic obsolescence management and aging ship maintenance strategy that ensures that the Ohio-class SSBN is just as capable, just as available, just as reliable on the last day of its 42 years of service as it was when it was delivered out of Electric Boat in the 1980s. So a very stressing equation where we have to make sure both sides meet the mark. Okay, and then the final thing I want to close with is the concept of challenges and opportunities. So I think that you've probably gotten a feel for both the great work that's being done within the government program management team, the government engineering community, the shipbuilders' design efforts, the shipbuilders' manufacturing improvements, and then, of course, the salt mine work in the Pentagon of building and convincing and protecting budgets. So that all taken together is a huge challenge. but it's also a significant opportunity. When you have a program this big and you look at the strain it's going to put on the industrial base, and then you combine it with the Virginia class program, which is continuing at 2 per year, and we're introducing the Virginia payload module, you realize that that combined is a huge challenge, but it also presents an opportunity. So we've been developing something for the last year called the Submarine Unified Build Strategy, or SUBS, and it's an approach. It's an approach to managing this entirety of effort within the submarine industrial base, so that we can, number one, ensure that we don't have cost or schedule growth in the Ohio replacement program. I'll come back to that in just a minute. And then number two, achieve efficiencies and synergy between the two programs where we can. So we're working very hard within the Navy, within the Department of Defense, and with Congress to make sure that we have the ability to take these unique and innovative acquisition strategies between the two programs, and even branching a little bit into carrier construction, which is done at Newport News, one of our 2 shipbuilders that work on submarines, so that we can, again, achieve those efficiencies. Going back to that cost growth, I know a lot of people raised their hands when Admiral Firebaugh asked how many people are involved in the surface ship world. For those of you that are involved in construction, I acknowledge that you look at this and you've heard the comments in the press over the last 7 or 8 years about the sense of urgency in figuring out how the Navy, how the nation can pay for Ohio replacement without impacting the rest of the shipbuilding budget. We take that charge very seriously within Team Submarine. We know that that it's a significant cost, and we know that the ability to adhere to that cost and maintain within those constraints is extremely important. And as we go through the program over the construction program over the next couple of decades, it is foremost in our mind to look for opportunities to reduce cost, and then to manage the program to at least maintain cost as we go through that, because we know the impact is impacting the ability of the Navy to build other ships. And that doesn't do any of us any good within the nation, and then of course down to the other communities. So in closing, it's all about challenges and opportunities. We have a great team across the board working on all of it, and we're looking forward to the next several decades as being a very exciting time in submarine construction and development. So with that, I think we're ready for questions. Again, to reflect what Admiral Firebaugh said, microphones in the aisles, and fire away.
Wait a minute, but just a second, Carl. I got a point to make before we get to the question. The first thing is that Ms. Bree Lang, who's sitting in the front here, is the public affairs voice of Team Submarine, and she's done a great job in pulling this together, and it's much appreciated. The second thing I would say is that the discussion that Admiral Jevele just made about the way the submarine program overall is constituted, the Virginia class, the maintenance program for Virginias and Ohios and 688s, and the construction planning for both Virginia and Ohio replacement is, to me, just exactly an embodiment of what the Founding Fathers said in the Constitution when they said the Congress is enjoined to maintain a Navy. And maintaining a Navy has a lot to do with ships and sailors at sea, but it also has a lot to do with the industrial base and the management of the programs. So it's what you summarized is just really a ringing ratification of what our forefathers had in mind. Carl.
Can you hear me? Okay, good.
There you go.
Okay.
Now it's on.
I have 2 questions. I guess one, this program goes over so many years. Is there a potential workforce development program with the aging of our infrastructure? I know this happened to NASA, where they lost the capability because it went on so long. And the second question is there a parallel propellant development program that matches up with this for the, the parallels this program?
I'm sorry, a parallel what development program?
In other words, is there a propellant development program that runs parallel to this, or are you going to use the same old propellant?
Okay. All right, yeah, I'll take them both and ask for some illumination. There's absolutely a workforce development effort. I mean, there's a significant ramp up required. If you just do very simple math, which I'm good at, if you're building 2 Virginias a year, okay, that's 2x. An Ohio replacement is 2.5 times the effort as a Virginia. So if you're building an Ohio replacement and a Virginia in the same year, now you're at 3.5x. So there's a ramp up that is fairly significant for the workforce, both at Electric Boat and at Newport News. And it's something that the companies are very aggressively developing plans for, and that the program office is very carefully watching down to the specific trade levels that they're going to need. And I'll let Will talk just a little bit more about some of the partnerships that Electric Boat has instituted up in New England to hire the right people.
Thank you. Yeah, so from the shipbuilder perspective, we're going to see a very significant growth both in resources and in facilities. So we've developed 2 separate plans, a facility master plan and a resource master plan, both of which take spatial analysis on the facility side that's directly developed from our manufacturing assembly plan development, and works with the state of Rhode Island in the case of Quonset Point and the state of Connecticut for our Groton facility, and maps out those investments that are going to be required in order to support the concurrent construction of the Ohio replacement program and the Virginia, including the VPM development. So that's a fairly mature process for which we're following right now. Paralleling that, which is a much harder process, is the resource master plan. Admiral Jabali mentioned that we have, as part of our manufacturing assembly plan development, identified down to the trade skill level those resources that will be required to build Virginia and Ohio replacement and the Virginia payload module. So we are working very closely with the Navy, with the state of Rhode Island, with the state of Connecticut, who's also working with the federal government to make sure that we have a training pipeline that starts in the public education system that will give us the resources we need for which we can then tailor the training for the skills that are going to be required for this ship's construction. So fairly long lead angle on that, but we are watching that and working that very hard right now to make sure we're going to have both the facility capacity and the people we need to go build these platforms. Good question. Thank you.
Yeah, and I'll add at my end. So as the program manager, I got to make sure my team also has the right experience. When we look at from a design experience, I have a phenomenal team. Mike Breslin is my technical lead. My ship design manager, Anthony Malarkey, both extensive design experience and in service. But now as we shift from design into construction, I got to leverage the experience of the Virginia class program office. So we have weekly meetings to leverage their lessons learned. I'm starting to hire my construction team. We hired a person with extensive construction experience, so it's the coordination with the program office in Virginia and bringing on the experience in my team. We're doing that very closely coordinated with the Virginia program office.
For the second part of your question, as I understand it, a parallel propeller development program. Propellant? I'm sorry? For the missiles? Okay, so the one person that we don't have up on this podium is a representative of Strategic Systems Programs. Admiral Terry Benedict runs that organization. The plan for this platform is to use the D5 missile with a life extension. So he's got a very active program to ensure that the D5 missile will remain in service. He's projected at least, I think, for about half of the period of service of the class, and then a follow-on missile development program to take it out to the end of this class. And for further questions on that, you'd have to ask them. But I know that they're very involved with a lot of the issues facing solid propellant rocket motor construction in our country, and they're very aggressive on making sure that that part of the equation continues. I'll warn him. Okay.
Sir.
Yes, sir. We've had a couple different presentations the last day or two that have talked about the cyber threat and identifying your critical program information and how that gets protected. I'm wondering how much of the burden do you all get, or is that a greater Navy burden on making sure your CPI is identified? That's on you, but making sure it's protected in industry and in the program office.
I will start by saying that that the tasking is the same for us as it is for every other program in the Navy, and you know there are many factors of the cybersecurity question. You've touched on just one of them: the ability to protect the critical design information and operating characteristics of the ship. And it's a huge impact on us, and it's a huge impact on the contractor as well, because all the design work is done at the EB and Newport News facilities, but we're very involved in their architecture and protection of the architecture of their IT systems and the protection of the data within them. But it's not an insignificant cost. Will, do you want to add anything to that?
No, I think, Admiral, you touched on the high points. It has been, I'll say, an evolving set of requirements as we entered into the Ohio Replacement Program, particularly where we are developing new capabilities, whether it's hardware with software-driven processors and how we control that, how we develop it, and how we secure it. So those requirements have evolved. I'd have to look next door to see if there's going to be anything else coming in that area. But it's a threat environment that I think we're all very, very concerned about and are taking extraordinary precautions to protect both the design tool application and the data, but then as well as the shipboard hardware and the systems that control those shipboard systems to make sure that we're cyber safe.
And I'll add one thing, that there's another degree of difficulty layered on for this program in particular, because as Dave Goggins mentioned, the design of the common missile compartment is a cooperative effort with the United Kingdom. So in addition to the basic critical program information protection, we have to make sure that we rigorously adhere to the terms of the Polaris sales agreement, and that the data that we transfer to the UK is safe in that transfer mechanism, and is also limited only to the data that we have agreed to share with the UK. So it's a multifaceted problem that we're very well aware of and work very hard at maintaining the requirements that we're required to.
Captain Benning, I understand that the cost, what I've seen in the press, is for the construction is about $100 billion. Do you have a life cycle cost estimate for the fleet?
We're working on, so as Captain Goggins mentioned, coming up, one of the key milestones is this summer, Milestone B, and we are refining a cost estimate to support Milestone B and the decision to enter into that. So
that would be the life cycle?
Correct.
Okay. Thank you.
All right, I don't see any more people standing. Yes?
I guess there's a lot of stories going back right now. One faction says we don't want it. Another faction, they want to keep it. What if any impact is that do you see coming up?
All right, so the question was, what impact would there be to our program if the United Kingdom were to change directions? There's been several press reports about discussion between the government in power in the United Kingdom and the shadow government as to the validity of the need for strategic deterrent. So the last thing I want to do is get involved in an internal discussion within the United Kingdom. But I will say that we have a strong tradition and a strong history of cooperation with the United Kingdom in a combined approach to strategic deterrence. And they have been a stalwart partner since their program began. Now, that said, we have constructed our program such that it is not dependent upon the success of the United Kingdom's program for our success. There are many interwoven ties, and it would be a disappointment to have to break them, but they would not impact our ability to succeed in the delivery of the Ohio Replacement SSBN.
I think without related to shared costs, the impact you don't have to share life cycle.
So the shared cost issue is not as significant as you might portray it to be. There's without a doubt some advantages to the way that we're doing this, but again, we would be able to succeed even if we had to break the ties with their program if for any reason they canceled their program. Now, that being said, I have no reason to believe that they're not going to build the successor class to their Vanguard SSBN.
Sir?
Could I ask a question about underwater shock standards? Can you make any comments in this forum about shock grades and standards and qualification process compared to Trident?
Yes, we are continuing to follow the same shock grades, shock program, shock qualification processes, and shock design processes we've used before. We are taking a hard look at the details of component by component, what level of shock it really needs to meet the missions of the platform. Again, as I said before, we're very cost conscious in all our technology work, and as those of you who work in this field of shock realize that shock is considered a cost driver. We've taken a hard look at that. We made some preliminary approaches, and we've been in an iterative design process to ensure that we get the correct shock level and the most survivable platform that the sailors and the Navy need out there, and Ohio Replacement will be exactly what it needs to be for shock qualification, and it'll be a very, very, very robust platform.
All right. It appears that there's no more questions, and Rick, I think we've wrapped it up.
I'll just say that in the grand tradition of United States Navy submarine shipbuilding, we are delivering you ahead of schedule.
Well, I want to thank, hello? Am I on? Okay. I do want to thank the panel. I want to apologize for having scheduled to do the last panel of the symposium. Putting a program together like this with as many intriguing panels is always a challenge. Admiral Firebaugh gave away my secret earlier when he was poking me in the chest for that. He said the reason we're last is because we're the silent service. They actually were hoping no one would show so they could talk to themselves. But gentlemen, thank you very much. That was a great way to end the symposium. I now declare the event over. Thank you.
We'll all be thanking you as we queue up on Route 50.